This is Dr. Hopple, and I'm going to help you with this problem. The first thing I want you to notice about this problem, or just be aware of, is that your answer choices, so here where we're going to have some answer choices, yours are going to be probably in a different order than mine, so you're going to need to read them carefully to make the proper selections. Okay, so it says select all the expressions that represent the area of the large outer rectangle in figure A below. So what it's saying is that we want to find the area of like this whole rectangle. So you can't really see there. But this whole rectangle that's kind of made up of the two smaller rectangles. That's what we want to find the area of. So first, if you remember the formula for area of a triangle, go ahead and write that in your notebook. So the formula for area of triangle. I don't know why I'm saying triangle. For the area of a rectangle. So what's the formula for the area of a rectangle? That would be area is equal to length times width, or you can think of it as base times height, which actually I kind of like that a little bit more. So base times height. And remember, all we have to do really is decide which one do we want to be our base, which one do we want to be our height, because since multiplication is commutative, it doesn't really matter here. So let's go ahead and we can choose 6 to be our base. So let's say that this is our base. And this is our height. Maybe you're thinking it's weird that the height goes sideways. Like I said, it really doesn't matter too much, so you could work this in a different way than me if that's your preference. But the reason I did this is so we can just think about all the different ways that we could write the base and the height. So ways we could write the base and height. Well, the base is going to be 6 no matter what. What about that height though? The height we can think of as being 3 plus 2. But at the same time, the height is also what? It's 5. So we could have the area is equal to 6 times that number 3 plus 2. Or we could have our areas equal to 6 times 5. Both of those would be correct. But then there's also this sort of other thing we could do. So another strategy we could try is what if we found the area of each of these sort of individual rectangles? So like for this rectangle here, the first one on the left, what would the area of that rectangle be? It would be 6 times 3 square units. And then what about this little rectangle here? What's its area? The base is 6, and the height would be 2. So we could also take the area to be, the area of the large shape is going to be like the area of the smaller shapes added together. So it's like 6 times 3 plus 6 times 2. So all of these would be good choices and correct expressions for the area of this rectangle. So we said 6 times 3 plus 6 times 2, that one's good to go. 6 times the quantity 3 plus 2, that's in our list. 6 times 3 times 2, that's going to be too much. 6 plus 3 plus 2, that's not really finding area. That's finding, like, how long would you walk if you walked down this side and then you went over this way. It's really like finding half of the perimeter of this shape, but regardless, definitely not the area. 6 times 3 and then we add 2, that's not going to be enough because that would be like if we found the area of that rectangle on the left and then we added 2 more square units to it. And that's just not going to be the square footage or the square units that we're looking for. So that one's not good. And then 6 times 5, that was in our list. You might notice that all of these expressions that we selected evaluate to 30. None of the other ones do, because 6 times 3 times 2 would be like 18 times 2, which is 36. 6 plus 3 plus 2, what's that going to be? That's only 11. And then 6 times 3 plus 2, that would be like 18 plus 2, which is 20. So those incorrect ones, we can feel confident that they're not right because they don't even evaluate to the correct thing.